Excuse me, sir. Yeah, I'm joined. You are able to see me, sir?
No. Mrinali, you are muted.
Yeah, hi, Smita. We are not yet able to see you.
Yes, ma'am. The video is on right now.
It's not connected.
So it shows that your video is on, but we can only see your banks. There you are. Hi.
Hello, sir. Hello, ma'am. Good morning.
So let's just get started since you're here and we don't want you to wait.
Yes,
I'm
ma'am.
not sure if the others are joining or not, but let's get started. So how are you?
I'm good, ma'am.
So what do you do, Smita?
I'm basically a teacher, ma'am, biology teacher
Okay.
in a school at Bangalore.
Ah, nice. Okay. And what made you take this course, biomimicry?
Yeah, it's a very fascinating subject as for now, what I felt. Once I made a presentation, ma'am, at ISRO. Recently for Teachers' Day, for
nice.
Science Day, they had an event for teachers. So then I had to present something on the science topic.
Okay.
Which was the theme for the Science Day for that year, last year. So then I made my presentation. I was going through related to the science goals, sustainable development goals. Then I happened to come across this term called biomimicry. I thought that would be one of the solutions that can give sustainability for the future world.
Sure.
So that's when I included that in my presentation, and I have done my session and that got over. But that's when it started me into the journey to actually know what it is.
Okay.
And I was looking for various platforms where online, especially where I can get into the topics and learn what actually it is. And being a biology teacher.
Right.
And I have done my PhD as well, ma'am. I'm an MSc PhD from biochemistry, background of biochemistry.
Okay.
So that's what has fascinated, and that's how the journey began. And as I get into the field and the applications are really fascinating, that's how the journey started. And
wonderful. Great. Very nice to hear that. So again, this session is for, yes, Shiva.
So Smita, what I want to know is, in your opinion,
yes, sir.
How easy was it to imbibe the principles of biomimicry with a biology background? And so the question that for you to think about is, how easy would it be for a non-biology person? Because we believe that this is open to everyone, but is there a biology bias to biomimicry from your point of view?
Biology bias is, no, it is open-ended, sir, as I understood, because the application is wide for biomimicry and it talks about various interdisciplinary subjects. But when it comes to biology, I'm able to apply it more. I'm trying to get connected more easily because I'm aware of the principles.
Right.
Okay. I have one question more.
Yes, sir.
So now you've been teaching biology.
Yes, sir.
So now most of the things in the world,
yes, sir,
are useful to us only when we can apply that in the real world.
Yes.
So can biology be applied, just pure biology, can it be applied to a particular human challenge?
Pure biology is, when we talk about, it's all about facts.
Okay.
That's what I understand, because children, when we teach, they look at it as fact. They think that it has to be something non-mug up and just represent. But that's not what biology is all about. It has a lot of scope, lot of application. And when I'm going through the course and the details of how each at the form, pattern, and the systems level, as you have mentioned in the videos, how each part of it can be applicable, right from the shape of a sunflower And so many other phenomena which you have mentioned, sir, in the case studies. I was really fascinated. And it's never a fact-based subject. It is so much of application-based subject. And that's what I'm trying to put it across to the children. So don't take it as a biology, as a fact, where you have to just mug in some principles and represent. It has so much scope beyond. And it's an interdisciplinary subject is what I have understood now.
Okay.
Because it's connected to physics, it's connected to technology, it's connected to every field, architecture, design, as you say. So many things are connected with the principles of biology. So that really is not only restricted to the biology subject.
Smita, fascinating listening to you. What I would suggest is if you have to go away in the middle of, if you don't have the time to stay till 12, I request you to write to us because we would like to have some more conversations with you on the subject of biology and biomimicry. Yeah.
Definitely, sir.
So I'll give you my email ID.
Definitely, sir. And one more small thing which I wanted to talk to you or take, in fact, your suggestion.
Sorry, Smita. I just have to say hi to Aussie. Hi,
Yes.
Aussie.
Hi, Aussie. So what do you do, Aussie? So Smita, we'll just say hi to him and then.
Yes, ma'am, definitely.
Yeah.
G'day, I'm Chris Deering in class from Australia.
Okay. Sorry, I didn't catch your name.
Chris, C-H-R-I-S. Last
Okay,
name. Deering.
Chris. Sorry, you
Your
put Aussie, so
name
we
says
understood.
EUSSY
Beg your pardon?
on the name tag.
Yeah, I use Zoom quite often for in my line of business, and that's the handle that I go under.
So how do we call you? Chris or
Chris.
Chris is fine. Yeah, Chris or CC, whatever you'd like. I don't mind, mate.
Okay.
Okay. So
Yes.
Chris, what made you take this course?
The fascination for,
Okay.
yeah, it's fascinating. I just thought I'm interested in biology. So anything like living, it's morphogenic expression, how it evolves is fascinating. And this
Okay.
is another lead on. I think entrepreneurship is highly linked with this course. And so I just thought, wow, I looked at the video and I thought, yeah, I'm going to give this one a go. Over.
Okay. And what do you do?
I used to be an electrician. I owned my own electrical company for 15 years. I'm an electrical engineering tradesman, but now I have a personal permanent disability in my forearms, and so I don't work anymore. So I've gone back to study, and I study agriculture and engineering for medicinal cannabis, and I've started to do a lot of experiments and evolve in that medicinal area.
Okay.
Legally.
Thank you. Thank you. That's Smita Aussie. That is Chris.
Chris.
Yeah,
Hello, Chris.
Yeah.
Nice to meet you. Thank you.
So
Yeah, nice meeting you too.
just to this session is just, we scheduled a live session just so there's a space and time for us to clarify any queries and anything that you want to ask and something that you want to do specifically by way of taking it forward. I mean, it's up to you, whatever you want the agenda to be. So that's a very broad agenda for this session. So it's up to you. Any questions? We're not going to be saying anything specific, teaching or anything. It's just a question answer kind of session. So please go ahead.
Yeah. So Smita, my email ID.
Yes, sir.
Is Shiva, SHIVA. At biomimicrycompass.com.
So you see the name right on the screen, Smita. You can just take it from there.
Yes, sir. Yes, ma'am.
Shiva at biomimicrycompass.com.
COMPASS.
That's right.
So write to us and like to know a little more.
And mine is Mrinalini at Biomimicry Compass. So, yeah.
Yes, ma'am.
All right. So any questions, clarifications? I mean, it's up to you, whatever you want to talk about.
So when we stopped, you had something to say, Smita.
Yes, sir. Yes, sir. I'm just coming to it. I just rather wanted both of your suggestion regarding the decision which I have to take, because as I'm so much into biomimicry now and getting fascinated more and more as I get into the details of the subject, I actually am more fascinated to pursue my PDFs now, as I'm already a doctorate with the basic biochemistry field of, I have done it on pharmacology. Actually, it's on medicinal plants and deriving certain active principles from the medicinal plants and checking their efficacy on certain animals with relate to, my work is on antioxidant and anti-diabetic properties of certain plants, medicinal plants. So that was my basic PhD background. And it's been 10 years I have left research and I'm into teaching, and I have taught at colleges and then moved on to schools now. But as I have seen in a post from Department of Science and Technology, Government of India, it's been offering now a WISE PDF for women, especially.
Right.
So that's a long running project, as we know, but I haven't, after my PhD, as I told you, I just left for research and moved on to teaching, because teaching is also at the same time my passion, being my passion. But now, as I read through the guidelines and the PDF availability now, and it's open till 60 years. So I thought, why not I try and continue with my research. And when I thought of it, it's only I thought of biomimicry being my choice of subject. So do you have any suggestions in that regard, ma'am?
Write to us. Let's talk about it later, because we'll give a chance to Chris and
yes,
Danny has joined us. So
yes, sir. Thank you.
You know, whatever help you need from us, we'll love to provide to you. And also we can tell you a lot of other things that we are doing around biomimicry. And if you need any help for your studies and all that, we are only too glad to help you. Also to help you teach biomimicry more. Let's talk about it at a later stage. I just want to welcome.
Yes,
Dr.
sir. Thank you so much. Thank you, ma'am.
Yeah. Hello, Dr. Ann. Welcome back.
Chris, in the meanwhile, while Dr. Ann is coming to, is there anything that you want to discuss about biomimicry?
No, not really. It's fascinating. It's very interesting. The way that, no, in general, to cut a long story short, I won't hold up people's time.
Okay.
I enjoy it though.
And one of the things that I would suggest to all the three of you here is something that we realized a little late, that biomimicry offers a lot of entrepreneurial opportunity, Smita and Chris. And so while we have been teaching biomimicry for the last 2 years, for the last 3 months we have been trying to practice what we preach, in a sense. So we've been, just like we ask the students to frame questions that can be answered from nature, and that can, so go back to the inspiration of the lotus sun paint example, Smita. And so therefore, why is it that a Smita or a Mrinalini or a Shiva or a Chris or a Anne, why can't any one of us be as enterprising as the person who discovered, who's making lotus sun paint, right? Because every day we're looking at nature. So why is it that only one entrepreneur looks at the lotus leaf and tells himself that I will make paint out of it? So if you can look at him as inspiration, then all the 5 of us here should do, in a way, I would call it, in a way, it's a duty to nature to be an entrepreneur, right? So normally entrepreneurship is looked at as a profit, whatever activity. I'm saying let's change our mindset from saying profit to saying let's look at this as duty for nature. And if we owe a duty to nature, you can understand how powerful lotus sun paint has been in the world of paint, because it doesn't cause toxicity and all that. So can we as a group look at nature and say, what are the opportunities that nature is presenting to us in order to make an industry out of nature? So I think that could be a fantastic quest for all students of biomimicry. And this is what I'm going to be saying from now on to students. So yes, teaching is very noble and all that, but what in entrepreneurship can you do to help nature along and to be inspired by nature? Otherwise, you know what we'll do? We'll just end up just like we are saying, you don't learn from nature. Biomimicry is about learning from nature, not about
Learning about nature.
learning about nature, what will happen is we'll simply become learners from nature. And that will become as stilted as biology, right? So I think, I don't know how we are going to do it, but from now on, the conversation should be around what is the entrepreneurial idea I can bring in looking at nature. Yes, Chris.
I took entrepreneurship at Madras last semester, and that's what brought me on to how the follow-on for this subject is, and it's highly linked. I did quite well in that subject and enjoy my entrepreneurial techniques and the things that I've designed and built in the past, and they've been successful. And this is just so linked, but from just a different angle, but such a highly valuable asset for those types of persons. It's I couldn't believe just the simple way that it's logged out. It has a business design program, so you just have to follow the steps basically as you go around the spiral. It's and you get to a really good result. So I love the course, and congratulations both of you for putting together a fantastic course. Thank you.
Thank you.
So what is the problem statement that we will define? Like Mrinalini has been constantly teaching in the spiral, Smita and Chris, and Anne tells me that she cannot come on screen because of but she's listening in. So I think maybe in the next program, or maybe you can write to us and say, these are the 5 or 6 problem statements that we are looking at. And then the magic of the biomimicry spiral, this process, will automatically take you to an entrepreneurial opportunity. All you've got to do is define the problem statement by asking, I have this problem, how does nature tackle this problem? So one of the things could be in the area of sustainability. You can say, I have a problem of making, I don't know, in the steel manufacturing process. The problem in the steel manufacturing process is something to do with, let's say, energy or something. How does nature manage energy, right? And then you get into a completely new line of thinking, and then you find the opportunity and you become an entrepreneur. And you make 100 crores, and then you buy your Mercedes-Benz Smita and drive it all over Bangalore.
Yes.
Yes, sir, that's really fascinating to know about the wide scope of biomimicry which is coming up. But how do we start up with that idea, sir?
But so look at the problems, no, Smita. So all you've got to do is find out what is the problem you want to solve, right?
Yeah.
So what is the problem I want to solve? I want to solve the problem of, let's say food getting rotten.
Yeah.
So then how does nature preserve a fruit for longer than it can, than the, so therefore you look for an alternative to the refrigerator then.
Yes.
I want to solve the problem of packaging is one big idea. How can we use nature-based packaging? I want to solve the problem of water in arid areas. How does nature help make way? The inspiration of the Nami beetle. Can we install those fog catching nets around? We have to start thinking very, very big, Smita, extremely
Yes, sir.
big, right? We have to imagine a world which is full of fog catching nets and constantly catching water. We have to think of our terraces full of flasks that will condense water in the night and fill it up in the morning. We'll have to.
Well,
You remember that study that Mrinalini is talking about, the Nami beetle?
yes, sir. Yes.
Namini, you want to talk about the Nami beetle?
Yeah, I think you have the materials till the 6th week now, right? So I would have already spoken about the Nami beetle. So the whole idea of using the Nami beetle, specifically the nature to solution approach, looking at the Nami beetle and actually looking at, okay, is there a way to harvest water from thin air? That's what we are talking about. So I guess what we are trying to say is, can we keep defining problem statements and not just leave it at defining a problem statement, but also looking specifically at ways to solve those problem statements? Because I think that's a responsibility as biomimics. And this is what we kind of tell our other classes as well. Because it's all well to kind of learn the basics and say, okay, biomimicry is fascinating and things like that. But what can we do about it? Can we practice it? Can we, more than just kind of be content with learning about what is going on in nature and saying, okay, this is a way to do it. Can we kind of practice it and start solving problems? And, okay, who knows, we may start up something and then it will eventually grow to something huge. So I guess that's the endeavor here, to kind of make biomimicry work. And given that we are the few people in the world now that who are actively thinking about biomimicry, it's kind of our responsibility to do it. I guess that's what we're trying to say.
So let's start making problem statements and help each other. So
yes, Chris, you had something to say, please.
I enjoy number 3 on the UN sustainable, on the 17 UN sustainable
Goals.
Thank you. And I've come up with a night for better health, and because I've got bad health, and one of them was to mimic my physio and the way that she does techniques on me. And I thought, how can I imply that through a practice? So I made this device that mimics her pressure onto my pressure points through this clamp, and it actually works really, really well.
Wonderful.
What did you mimic, Chris? What did you mimic?
My pain physician.
I know, but what organism did you mimic from nature?
It was a mammal. It was my physio. It was a human being. Sorry, it wasn't more per se nature.
You said something about a cheetah. That's what I said.
A teacher.
Did you say something about a cheetah or something?
No, I'm sorry.
Okay, so you're looking at the way your physiotherapist does the action and you're mimicking that same action. That's what you're saying.
Yeah.
Okay.
Yeah.
Wonderful.
And it worked all right. And it's for pain too. So that helps. That for number 3, that's a good
Great
solution.
So only you are using it now, or have you tried to do something more with it?
I'd like to put it out there. I'm very poor myself. So I haven't done anything, but I'd like to put it to some entrepreneurs and actually crowdfund it and go in some better directions.
Right.
But I haven't as such though. I've told it to a few people and they're astounded at the idea, and a few doctors. Yeah, over.
Wonderful. Congratulations on that. It's nice to hear that you've created something out of it, and we hope to hear more about how you take it forward.
Thank you.
So Dr. Ann has said that you have a question on systems thinking approach. And you've posted it on the Google Sheet. So I'm just trying to look at it and try and see if I can get it here. Just give me a second.
Can I just say, the more that a lot of people, you've changed my thinking forever. Like you said, one in the first few lectures, and the more the people can adapt this type of thinking in the way, the practices that it is, the more sustainable everyone's going to be and more happier. The win, it's just a win-win situation. It might be a lot harder to get to the result, but you've changed my thought pattern, and I'm quite directly driven, polar direction. So for you to open up another chain, congratulations for allowing me to, I really like this course. Thank you.
Wonderful. We're glad to hear that it helps you change your mindset, which is a wonderful thing to hear. So
similarly, while Minali is looking for the Google form, this was Smita and Chris. We spoke to Anne last time. We have made one problem statement, and that has led us to a fantastic journey now. So the problem statement, so we looked around and said, what is it that is causing harm to nature? And we looked at burials. So in India, there are two types of disposing of the human remains. One is burials, the other is cremation. We can't do anything about cremation. So we said, how do we, burials apparently, the coffin, it takes about 15 years for it to disintegrate. So we said, how can we make it more friendly to the atmosphere, earth? Then we said, can we design coffins that can easily be decomposable? And so you put the dead body in the coffin, and the dead body along with the coffin decomposes within a very short time. And then we found this fascinating material, Smita, there's something for you to work on called mycelium, mycelium. And mycelium, apparently, you can make any packaging material out of mycelium. So we said, why not make coffins out of mycelium?
Oh, it's lovely ideas.
Because of the cultural problems with coffins and all that, we
Yes,
have
sir.
focused to now looking at mycelium as a packaging material, and are working on it. And we should hopefully in the next 3 or 4 months have something more to say about it than simply, patting our back and say we thought about it. So I'm just telling
Yes,
you.
sir, definitely.
So,
Mycelium is a fungi, actually.
yeah. So actually,
Which is the
last
value
live
in,
session we spoke about. Sorry, Shiva, go ahead.
which is the value in looking for problem statements, because like Chris was saying, you never know where the problem statement leads you. Yeah.
Yeah, so we created some samples to find out how we can do packaging with mycelium, and so that's kind of something that we want to work on and see how to do that.
Yes, Chris.
Dr. Ann, yes, Chris.
Just to add to that, and then you could also look at what type of fungus would break down, like rotten and the flesh, what breaks it down the fastest. So you could possibly inoculate the inside of the coffin with that as well to speed up the process.
Absolutely. Yes. Thank you for the idea. Yeah. Dr. Ann, I can't see your question. Would it be possible for you to type it out here? I know you're having trouble with your microphone and camera, but if you just type out your question, we'll try and see if we can discuss it and talk about it.
Yeah, this is the one that Mrinali was talking about. This is what we could do in the lab.
Yeah. So we created that, took agricultural waste and put it in a mold and inoculated it with mycelium spores. So that's the sample we created, and we want to use it for packaging, etc. So we're trying out with different strains and seeing what works best by way of mechanical strength, flexibility, etc. So the idea is, can we at least start with replacing thermocol and styrofoam and things like that, because that's a widely used packaging material here in India, and obviously a lot of it just lies around not being recycled. And the best part of this is, once you finish using it, you just kind of throw it in your garden and it will just decompose. So there's no waste that you're creating out of it.
We have a partner. We have a partner who's made this, who's been able to make it in the lab. So now we are looking at different types of shapes and packaging material. So it's just growing, but it's still in the very early stage, but hopefully. But more importantly, we'd love to hear some problem statements from all of you.
So recently I was going through articles, like I was reading about even nanoparticles, which whose applications have been widely spread now in various fields, right? Say about agriculture, in cosmetology and all this. But as I see this recently, even the toxicology aspect of the nanoparticles have come up, where how those nanoparticles get into the soil or into the atmosphere and causing so many human-related diseases. So I was thinking in that terms recently on how to apply biomimicry to combat this issue. Then I was also have also come across alternatives, like who already people have started working on it with relative microorganisms have their own ability to synthesize nanoparticles at their level. And these are completely alternatives to the chemical nanoparticles that would completely replace the So it's also, maybe can it be related to biomimicry, because nature itself is involving in creating nanoparticles. In the field of remediation, maybe we can use where toxic chemicals would be reduced to nano level, and that can be used for further applications, replacing for, I mean to say, synthetic nanoparticles. Because there are so many fungi, plant materials, even microorganisms that have their level, and those are completely natural, but only issue was with relate to their stability. That's what I have understood. But they definitely have 90% of effectiveness as just that of synthetic, but only thing is related to their stability. So if we can work on in that aspect is what my thoughts are about, so that we can create fertilizers, we can at the nanoscale, which maintains the sustainability of the soil.
Okay.
So that they do not affect the soil microorganisms, because soil microbiota is a very, very important aspect that we have to take care when we talk about agricultural sustainability. So these are the aspects and some of the thoughts which I am recently trying to apply my understanding of biomimicry towards nature's problem. This is also causing, because even the pollution is leading to so many nano scale, it is getting released in nanoscale where we don't know where it's getting accumulated. So there is a process in biology where you say it first gets accumulated, then magnified, and then transformed. So there are the 3 stages at which this process occurs. And as the prey and the predator process occurs, so it starts from the soil, microorganisms to plants, plants to humans, and finally into the system. So this is one aspect, is what I'm thinking on.
Okay. Let's work on that. Let's exchange views. You also said something about remediation. Why did you say that?
Yes, sir. Even these microorganisms, which we, if we tend to release them into an industrial effluent or an effluent which we can degrade it faster, using the effluent, the microorganisms convert that effluent, which has and convert the particles into nanoparticles, and those nanoparticles we can use it. So we are looking into 2 systems there. One is we are trying to remediate a particular source which is highly toxic. At the same time, we are trying to use a natural way where it gets remediated, and the byproduct are our nanoparticles, which can be used in the industrial level at whatever product we wanted to design, whether it be aligning them with a fertilizer or aligning them along with a cosmetic, whichever we wanted to use through, or making any material out of that nanoparticle, which is degradable, so that that does not get accumulated into the human body. And
very good, nice. I like the thinking. Very, very broad, very, very good imagination. Good, nice.
Thank you, sir. Thank you. I'm just thinking of this aspect of how can we use remediation process. And even I'm thinking in terms of litter, sir, leaf litter. Even leaf litter or the biological materials have so many particles which are still not, means though they are detached from the plant, they do have certain molecules which if we can use them along with certain fungi or microbes and treat them to remediate certain waste, and that waste now gets released to produce nanoparticles, which we can extract those. That's what I was, my plan is all about.
Oh, wonderful. Nice to hear that.
So that is the aspect what I am trying to look into, and I don't find any papers working especially on leaf litter, but leaf litter is having so many biomolecules which have the ability to convert or produce nanoparticles. And these are sustainable nanoparticles, and we can use them in various fields, like the application of nanoparticles, because nanoparticles have been widely used nowadays in whatever industry we talk about, but they are causing toxic. There is a toxicology aspect of it.
Okay.
So I'm looking at how to combat the toxicology aspect of the synthetic nanoparticles. That's where this all thought process have come into.
Good,
Okay.
Smita. So let's keep in touch then.
Yeah.
Yes, sir. It would be my real pleasure that if I can work in this aspect and if you can really provide me guidance on this, I'd really like to take up this project, and I don't know what else can be the application aspect of it. I need more of your suggestions and ideas.
Sure, sure.
Sure,
You can write to us, and we can talk about that.
Yeah.
So, Dr. Ann, we see your question.
Sorry, Chris has something.
Sorry, go ahead.
I was just going to add to what Smitha was saying is a metagenomic study. I study microbiology and I've done environmental biotechnology. So a metagenomic study of leaf litter would be good, and that would tell you what types of microbes you have in your leaf litter. Then you could go on that and work black onto plates and plate them and see what type of secondary metabolites you could get out of those, and then what nanoparticles it could produce. Over.
Exactly, Chris. That is the biomolecular aspect of the plants is what we are looking into.
Right.
Even the microorganisms, they have so many chemical constituents
So
which
good.
have in nature able to reduce the toxins to nanoscale.
I'm glad that we've been able to whip up all this passion with the two of you. So let's quickly look at Dr. Ann, please.
Yeah, she's posted a question here, and I'm not sure everyone can see it. I guess she's saying, I have some students who are looking for research, so I advise them to look for topics in detail. When I learned about systems thinking, the approach is the opposite. So we are focusing and for the other, we're looking at the big picture, but I'm not able to put it together.
Dr. Ann, I know that you can't come on video, but can you not speak? Because we're not able to understand the question. It seems to be saying that there are two opposing views as far as what the opposing view, the systems thinking view is the big picture view. And there seems to be some opposing view, which means the narrow picture. So the audio is also, so I'm sorry, we're not able to understand the question, Dr. Ann. Maybe I know that we owe a reply to you, so maybe we will say hello to you on the mail, and you can send us the question, and we can correspond on the mail. Yeah. I don't know what approaches you're talking about. I know one is a systems approach, but what's the other approach? I don't know. Can you prompt the microphone? No, I can't.
So let me try and do that.
If you're asked to turn microphone on or turn.
Yeah. I'm just trying that.
Sometimes it works. Sometimes some computers and yeah. Oh.
So are you able to connect to your microphone now? I just tried to sort of prompt as Chris suggested. I'm not sure.
If your microphone, Ann.
I just did it, Shiva.
No, I'm asking Ann to check her mic.
So not sure why it's not happening.
All right, that's okay.
Right.
Yeah, Devraj, you have any questions?
Hello, sir. Can you share some automotive examples?
No, we can't. Devraj, you need to have a problem. Last time we said, I cannot give you an automotive example. I need a problem from you. I need a problem statement from you, and then we'll go through the normal biomimicry process that Mrinalini has been teaching you. So if it's a problem statement, then we go to nature. We find out what in nature does that. We cannot simply give you a automotive example, right? So tell us.
If you're just interested in a case study, Devraj, I would recommend that you look at Ask Nature and go under innovations. And you could just find a bunch of examples pertaining to various industries in that. So you may find something of interest there. So if your interest is in a case study per se, you can do that. And
if you put a gun to my head and say I want automotive examples, I can only talk about speed. I can talk about whatever automobiles do, right? The process of automotion, like last time we had discussed. So if you can go to the factory and find out what is it from the beginning to the end that's happening in the factory, and what is it that nature can do to reduce waste or reduce energy or reduce some effort, can you bring in something to do with nature to let's say not waste something? Can you recycle something? So I think your answers will lie more in the design principles of nature, which is nature does not waste any energy. Nature does not use toxic chemicals. Nature looks for products that are, nature looks for local resources. So it's more in the design thinking area of the design principles area of biomimicry that you can find answers, rather than in the ask nature, rather than in the typical process of biomimicry. So I would suggest to look at the design principles, explore all the 10 design principles, and find out if you can use one or two or all of them in your factory, where you are starting from raw materials up to your finishing of the car, right? Or whatever you're doing. So in that process, is there something that you can intervene with one of the design principles? Can you save some energy? Can you look for local resources? Can you recycle something? Can you not use toxic waste? So whatever nature is doing, can you look at that, Devraj?
Okay, sir. Thanks. Thanks for the explanation. Next time I will come up with the problem definition.
Sure, thank you. And again, while talking about design principles, it was good of Devraj to have prompted that. Chris and Smita and Dr. Ann, I think we should also look at what I just said, those 10 design principles. I don't know whether you've already come to that in the course. Have you? Have you
The
come?
nature's design principles, the 10 of them, is that the one?
Yes, we are in
Unifying patterns.
5 principles are covered.
Lila, I'm talking to Smita whether she's covered it, Chris and Smita.
Sir, I'm still in the week 5 content.
Okay.
Unifying
So there will be
patterns
some
are the-
detail on the 10 unifying patterns or design principles, as we call them. And many times, as biomimics, I think we should pay more attention to that as well, because it's not just about the design spiral. It's also about trying to see if we can imbibe these principles, and it's just not just for biomimicry, it's for everything else as well. So, yeah.
Like, I'm just writing piggyback on Mrinalini, what she said, Smita, just to help you understand. So we do this program called design thinking, right? So design thinking is what we teach. Now, when we do design thinking, our students come with a lot of ideas.
Yes,
But
sir.
we tell them to go back and look at the design principles. For instance, supposing one of the students comes back with an idea, a solution to, let's say, make a product, right? To make things better, to help the doctor or something. But if that product has made with plastic, then there is no use having that product.
Exactly.
So we send him back to the design principles and say, find out how nature would have designed this product. And
Yes.
therefore he comes back and says, I don't want plastic, I'll do something else instead of plastic. So it comes under what Mrinalini teaches in that whole spiral called evaluation, right, Mini?
Yeah. Also, yes.
How do we design in such a way that we don't go against the way nature designs?
Yes, sir.
I live off grid, so it's quite easy to adapt nature's techniques.
Yes. I wonder why designers are not using these techniques yet. I wonder why. I don't know why designers are not looking at. I know. I don't know whether Mrinalini, do you say that the cell phone charger example in the class?
Yeah, I think it'll probably come up in week 6, Shiva. It's in the week 6 modules. We discuss the nature unifying patterns, the design principles in detail. And we will be talking about the example that Shiva just alluded to.
You can explain it briefly then.
Yeah, sure. So, one of the unifying patterns or design principles in nature is nature uses only the energy it needs and relies on freely available energy. And an example of the application of that is from Tanzania. There is this company, and so typically in countries like Tanzania, everyone has a mobile phone, but they don't necessarily have access to electricity to charge the mobile phone. So what happens is, and this happens in India as well, that people have access to a mobile phone and they use a mobile phone for their daily activities, but they don't have electricity or easy access to electricity to charge the mobile phone. So what this company has done is they have created a bicycle charger for a mobile phone. So what you do is you've created a charger using the dynamo that is available in your bicycle. And as you cycle, you can charge your phone. So this is, an easy and direct application of using the available energy to do something. So, and this is something that we talk about to our students on campus as well. So on campus, and maybe you've not seen the campus that we are in, but it's a large campus and it's quite green. It's a green campus as well. So you see a lot of bicycles around, and you have students rushing from class to class and trying to rush back to their rooms to pick up their chargers to charge a mobile phone. So why can't we just create something like this, that anyway you're going to be commuting via bicycle on campus and you charge your phone as you do that as well. So it's just, thinking like this that can help us kind of imbibe this in our heads as far as design principles are concerned. And as kind of Shiva also pointed out, that the design principles are not just a biomimicry specific thing. It could be applied everywhere as well. You could think about it, and in fact, for me, it has kind of helped me in multiple ways, that you look at it and say, okay, can I do this in my, in my life, in my activities as well? And can I take that as a lesson from nature? So that's kind of important as well, we think.
Personally, the design principle about the nature is resilient to disturbances, right? There's a lovely design principle called nature is resilient to disturbances. So when there is a fire in the forest, nature builds nature has resources to come back to life. So apparently there is someone who is here.
So that's the, what happened? So that's the pine forest, right? So every pine tree, even though the entire forest was destroyed by a fire, every pine tree has two types of cones. One are the cone is the reproductive part, and one cone is not typically doing reproduction at all. But especially it's a resinous cone. So when it is exposed to high temperatures like that of a forest fire, it kind of bursts open and throws the seeds around, and that helps the forest actually regenerate. So this is an example we talk about in the video modules as well, to find out how nature is resilient to disturbances and how we can kind of bring that up using the principles. So there are 4 or 5 key concepts that you can look at: decentralization, building redundancy, and things like that, in order to help build resilience in the systems that we create. So that's a very inspiring example.
So personally in my life, I have now decided to use biomimicry to come back from a bad experience using nature. How can I build in my own life second and third and fourth pine cones, which when I'm completely stressed or when I'm completely in a very depressed state of mind, can I have separate pine cones that will help me come back to life? So therefore, we are learning that biomimicry can also help us behave change our behavior, and not just for technology and products. How can we learn from nature in order to change behavior in our own life and in other people's lives? So it can be a human resource, that sort of, we can also learn how to build teams and, resilience and things like that using biomimicry. Yes, Chris.
Just as an example for that, a good example would be ants. I love ants. Studying that's mycology.
You're the first person I have heard who says I love ants. Nice, go ahead.
Mate, people should respect. They help us clean up.
Absolutely.
They do all our work for us. They're so rewarding. Did you know that there's a hospital in South America that they go into each year, each day at a certain time in the afternoon, and they clean up the hospital. They let them do it for about an hour, then they leave. They are so resilient, rewarding. Sorry, ants. I won't go on about it but ants, as you were just saying, I just want to add on to what you were saying, that if people could be more like ants, we'd be more successful. And that's a similar pathway to what you're saying.
Very good. Nice.
Very nice
Example.
example. Yes.
You can use that next time for resilience.
Yes, absolutely.
Thank you.
Lizards, lizards keep growing their tails, I was told. Lizards.
If they are cut off.
No, they also leave the tails behind, which is wiggling. That's a different application.
Yeah, it puts the animal off. It's clever, isn't it? So that could be adapted to some technique. If you're trying to, like a scarecrow, if you're trying to maybe that, you could somehow leave the scarecrow there, and that could be dropped off, and then you might be able to, yeah. Sorry for speaking out.
No, very nice. This is exactly, I think this discussion should be about. We're all exploring biomimicry to find out where is the opportunity.
Yeah, absolutely.
Thank you.
Did you hear about this person in Bangalore who is making sewage systems, right? Using
So that's the company called EcoSTP. And maybe I can share the video quickly just to kind of give you rather than me talking about it, it's nicer if you, let me just quickly pull out the video. Give me a second.
I think that video that was on shark skin, on how they've got nanotechnology with how the bacteria can't stick. There's fascinating applications for that in the future.
Sure.
Someone can make a dye, and then they could cast that and sell that to multiple people. Then they could cast all of their appliances out of these, just a standard dye.
Right.
You got the video?
So let me just show you that.
EcoSTP video.
Yeah. 1 sec.
And even in this regards, I would just like to add that how snail shells, there was a question in one of our sessions, like snail shell, how do you apply it to biomimicry? And have read that snail shells have an ability to replace minor damages.
Right.
Self-healing.
Yes, sir.
How can we apply that to roofs when they get damaged after hail?
Yeah. They're able to manage and produce calcium carbonate and patch the gaps. So how do we think about that in applying it to for patching up the building cracks that would get due to more humidity or due to moist excessive rains?
Got it, Minnie?
Yeah, I got it. Can you see my screen?
Yes.
Okay.
80% of the world's wastewater is dumped untreated, leading to poor sanitation and disease. This is a particular problem in Bangalore, in India, where the lakes contain so much sewage they catch fire. Treatment plants can be expensive to run. Waste is usually broken down by bacteria that feed on oxygen, provided by costly blower motors. Bangalore resident Tharun Kumar looked to cows for a solution. These master digesters have 4 stomach chambers containing bacteria that don't need oxygen. As grass passes through, the bacteria in each chamber break it down into smaller parts, converting it into nutrients, gas, water, and waste. Tharun and his team designed a treatment plant to mimic this. It uses bacteria from cow dung, so no need for blower motors. In fact, it doesn't require any power, as gravity moves the sewage along. The further it travels, the cleaner it gets, as solid waste sinks to the bottom and the rest is converted into gas and clear water, which is safe to use outside. 50 treatment plants have been built, and the team plan to export the design to Africa. Could cows help solve the world's sewage problem?
Well done.
So we spoke to Tarun, and
That
we
was a lovely
to Tarun
example,
Kumar.
ma'am. Thank you.
Yeah. So we spoke to Tarun, and he was, telling us about the whole, how this came about. And, funnily enough, sewage treatment, especially in India, and I'm not sure how it is in Australia, sewage treatment is mostly about blowing air over the sewage.
That's it.
And
Blowing
most of
the
the
air.
solutions are talking about we blow air better than the other type of thing. And that's kind of what got him thinking that, why are we doing the same thing over and over again to treat sewage? And is there a different way of doing it? And interestingly, Tarun does not have any background in wastewater management or sewage treatment or anything. He has a background in IT, but he just asked the question, is there a different way of looking at this? And that's how he came up with looking at the cow's digestive process, and came up with this design with his team. So that's a very interesting case study on how this came about.
So I have this message from Dr. Ann. She says, could you elaborate on systems thinking about how we can solve a problem? Okay. It's a very generic answer, Dr. Ann. But why systems thinking is useful for solving a problem is because now, so what is a system? A system is elements connected to each other. So I have what is called a digestive system. Now, in my digestive system, what are the elements? The elements are the tongue, the epiglottis, the throat, my stomach, my liver, my kidney, my large intestine, my small intestine. All these are elements. All of them together help me digest the food. So the digestive system consists of elements, and all these elements are dependent on each other. I cannot say I want only the stomach, I don't want the tongue. The tongue cannot say I don't want the stomach, I want only the throat. It cannot. So all these elements work together to achieve a purpose, which is digestion. So this is systems thinking. Now, why am I saying that systems thinking, learning systems thinking helps you solve a problem? Is because when you look at a system, supposing somebody, you cannot simply say the stomach has some problem. You have to understand the stomach has a problem, probably because the kidney has a problem. The kidney has a problem, probably because the throat has a problem, whatever. Now you take a system like IIT Madras. When you put yourself in a helicopter and go up, what do you see? You see a campus. But what do you see in the campus? You see security, you see the mess, you see the hostels, you see the faculty, you see the director, you see the students, you see the residents, you see all of them. Let us assume that students have a problem in studying, and you're worried, saying, why are students losing marks? Normally, the immediate tendency is to tell the students, study harder, study harder, study harder. But if you're a systems thinker, you will ask, what is causing the students to do badly in exams? And then when you talk to the students, you will find that many students are not having breakfast in the morning. And because they are not having breakfast, they're coming hungry to the class. Then you ask yourself, why are they being hungry? 2 or 3 reasons. One, because the timing of the class. 2, maybe because the food in the canteen is not nice enough for them to eat. So the problem is not with the student, the problem is with the food in the canteen. So instead of looking at the student, you try to solve the problem of food in the canteen and find out if you can make the food in the canteen more nutritious and more accessible and easier for the student to eat. So therefore, you can probably say the student, if there is no time for them to eat, then can you put a vending machine near the classroom that they can access a sandwich from? Or if they are upset about going to the canteen because the food in the canteen is not good, then can you make food in the canteen so tasty that the student wakes up in the morning, goes to the canteen, eats, and then coming back to class? So the performance of a student is not linked to the student, but to the canteen. And this you can find out only if you're a systems thinker, because you look for a problem somewhere else rather than directly in the person who is coming to you with the problem. So that is where I think your question is, can you please elaborate on system thinking? So therefore, you look at everything as a system and you say that the problem may lie elsewhere, some other connection to the system rather than in that element itself. It's a fascinating topic, systems thinking. Dr. Ann, is there a response from you? Sure.
I think Anne just
All right.
responded.
Yeah, I think she just responded. Thank you. All right. Time is 12 o'clock. For Chris, it's time to take a nap, I think.
4:30 p.m. Yeah.
Did you watch the World Cup, the Women's World Cup?
The World Cup soccer. Oh yeah.
Soccer, yes.
Oh, that was terrific. Yeah, I thought you were talking about that. I was thinking what cricket match was on. Yeah, but yeah, I did watch the World Cup soccer. I'm into cricket. I love cricket too.
No, soccer. We watched it. Great interest. We were all envious of you guys in Australia because you got the chance to watch it.
Oh wow, yeah, it wasn't too far from where I am actually here at the moment. It's about 4 hours drive is where the games were played.
Okay, wonderful. So you're a cricket fan, but
oh yeah, I love the cricket. Can't get me away from any 2020 match, which is starting in a few weeks. The women's tournaments in Australia. Oh.
Sure, yeah.
Sorry, Chris, I'm sorry. India will beat Australia any day.
No,
I'm just joking.
That's a good debate, that one.
Oh, by the way, Chris, I worked with Greg Chappell. On creative thinking.
Oh wow, yeah.
If you write to me, I'll give you some more details on the work I did with the cricket team when Greg Chappell was the coach in India.
Excellent. Good work. Yeah, he's a legend. I'm 50 next year, so I was around when he played, so I do know about him.
Yeah, Greg Chappell taught me a lot of good lessons, nice lessons, great lessons on cricket and on life.
It's a peaceful sport. It's very nice. It's a gentleman's sport, they call it, and you can see why. There's no real fights that happen in cricket. It's very nice.
All right. Thank you, Smita. You're in Bangalore, Smita?
Yes, sir. I'm in Bangalore present.
Okay. So thank you, Chris. Minnie, you have something to say?
No, nothing. I mean, if there are no further questions, and I don't think we're going to get anyone right now because we're at the fag end of the session. And so we can probably wrap up if there are no further questions. And we hope to be in touch and, hear from you how you want to take your journey forward and what you're doing to do that. So nice to.
We had a terrific Saturday. Thank you.
Yes.
Thank you too. Yes,
Thank you
very
and
nice.
all the very best.
Thank you.
Very nice.
Bye-bye.
Thank you, sir. Thank you, madam.
Sure. Bye.
Bye-bye.
Bye. Bye, Devraj. Bye, Dr. Ann.
Bye.